Okay, guys. So these two questions, number 12 and 11, and I think it makes maybe a little bit more sense for us to talk about 12 first. 11 is actually conceptually, it's an easier question, or should be. That's the way to design it. But I think in describing what they're talking about here, it makes sense to do 12 first, at least as we talk about it. Number 11 has, and actually both of them, I think, have a little bit of a kind of caveat that we have to pay attention to that they don't describe. And the fact that in these two, what they're saying is that our variable h is a positive number, okay? When I just say x is equal to h in like number 11, okay? When I say x is equal to h right here, we understand hopefully that x equals h, then h can be anything on the number line, right? They're making the assumption that we know it because they're not putting a negative sign there. We're going to assume that it's positive. I think that can get you maybe in a little bit of hot water if we're doing the average rate of change, or sorry, just the net change might mess your sign up if we don't pay attention to that. Okay, so that's really my only concern about this question. But let's talk about this number 12 before we do anything. So it says a function is given, f of t equals 9 divided by t. T is equal to a, and t is equal to a plus h. So those are your input values. That's ultimately a value on the x-axis, and this is a value on the x-axis. Okay, they're using t because probably trying a function that's probably describing time. I'm going to refer to it as x. Okay, so 9 over x. X equals a, and x equals a plus h. You can view it that way and still be fine. And the reason I want to view it that way is because I want to graph this thing. Okay, so I graphed it 9 over x. So it gives me that function there, which is just we'll call it a reciprocal function. Okay, nothing too bad there in regards to graphing. But now this is what they're talking about. Okay, I'm just going to zoom in on just the first quadrant of this. This is the idea, guys. They're saying your a value is some input. So let me just change my a value to 2 here. And really, to be honest with you, the way they're viewing this is that we don't have, oh, I didn't want to do that. I hid my axes. I wanted to show my axes, but no numbers. There we go. Still hid my axis. X-axis. You guys, I can't see it on my screen. You guys can see the x-axis up there? Okay. All right, so the idea is that you have some input A. Okay, is that going to garner some output f of a on that curve? Okay, and we can say that A can be any value it wants to be. Okay, now they're saying a plus h then. A plus h means take your a value and add something else to it. Add some h quantity to it. And hopefully we realize that that should then take and develop a point to the right of a, correct? Does that make sense? And that's the idea that we want to make sure that when we're assuming that h is positive. Because we don't want right now in this understanding to be over there. Okay? It wouldn't be a huge deal. It really wouldn't be an issue at all if we were just doing average rate of change, because then things will work out. Signs will work out right. But if we're just doing net change, we want to make sure that we've got that point over here to the right. Because we want to show my net change is just the difference in your y values. So we want to show that it's decreasing. Does that make sense? If h was negative, we would see that when I do the subtraction in a particular order, we could maybe going from right to left see that we're increasing. So that might be kind of a thing that we think about and discuss later on. But f of a and f of a plus h are your y values that you're going to do your net change with. Okay. The calculus of this, guys, you remember yesterday I talked about how that is a secant line, right? Okay. If we see here, if I just connect that, okay, the slope of that secant line is an estimation for the slope of this curve at A. Okay, but what happens is that we want to make that A plus H we want that secant line, we want those points to be closer and closer together, okay? Because the closer and closer I can get those points together, the more that secant line represents a tangent line. Does that make sense? And the slope of that tangent line, and then would be the slope of the curve at that point. So this is a very useful calculus concept that we're using here, and these are kind of the initial steps for conducting a calculus problem. All right. So what we want to do is to find the net change. Remember the net change, and I sent an email out yesterday kind of explaining, because I don't know if we spent enough time talking about it yesterday in class. Net change is, if I have like, I think we talked about income. If I have like $1,000 income week 1, and then I have a $800 week income week 2, that's a net change of $200, right? And it's decrease, okay? The stock market uses net change every night when you watch the news, and they talk about the stock market either increased or decreased, okay? The positive or negative tells you positive increase, negative decrease, right? So here we're going to do net change, okay? This function was f of t, or I'm just going to call it f of x actually, is equal to 9 over x. Okay? 9 over x. So we wanted to evaluate this thing at x equals a and x equals a plus h. Okay? So x equals a and x equals a plus h. Just kind of keeping in line with how we maybe usually do this with like lines or stuff. Most people will say, this is my x sub 2, and this is my x sub 1, and this is my y sub 2 and my y sub 1, right? Does that make sense? So let's do it that way. So then I'm going to evaluate, I'm going to plug this thing in to find net change. Then we're going to go f of a plus h minus f of a. Does that kind of make sense? Okay, that's the difference in those y values, right? Okay, so if I subtract those, so I'll have 9. F of a plus h is plugging a plus h into here. So I have 9 over a plus h. Okay, minus then, okay, now I'm going to plug in a. So right there, so I have 9 over a. Does that make sense, everybody? Now, so that's my net change. Now, it's not one fraction, so I think if you type it in that way, web science is going to throw a fit. So we need a common denominator, right? Common denominator a times a plus h. So multiply these things by those things. Okay, so now I'm going to get 9a up top over a times a plus h minus then 9a minus 9h, correct? Okay, all over then a times a plus h. Is this okay with everybody? Now I've kind of, I know what I've done here. I've actually made, this should actually be a plus sign and a minus right there. Because I distribute that negative 9 to the a and a negative 9 to the h, right? Does that make sense, everybody? Okay. So what can, if I combine those in the one fraction, what's going to happen to the positive 9a and the negative 9a? They cancel out. And you're left with negative 9h over a times a plus h. Okay. And that then is what we refer to as our net change. Okay. That is our net change. How does that vary? How does that differ from average rate of change? Okay. So that's the total amount that I've changed. The average rate of change is then to divide that by the difference of your x's. Does that make sense? So the numerator is the difference in our y's. The denominator is our difference in our x's. So let's take that number now. Okay, that quantity, whatever it ends up being when we know what a and h are. Okay, and we would then divide that by that distance right there, and that will tell me the average rate of decline. Does that make sense? Okay, so when we write it maybe in rule form, it'd be f of a plus h minus f of a, but then we would divide that by the difference in our x's, so it was a plus h minus a. Does that make sense? Okay. Well, if that's the case, what is a plus h minus a? H. That should make sense, and that's why I made this thing blue, is that we're dividing on that interval. We're dividing by that interval that is representing that distance between A and A plus H. And that distance then has to just be H, isn't it? I start at A, and then I move A plus H, or sorry, I move to a new location called A plus H. And the total distance I moved was just H. So we're going to take the negative 9H over A times A plus H. That's your, remember, that was your net change. Whoa. And then we're going to divide it. We're going to divide it by how much we moved in the x direction. We moved just H. Well, how do I divide by a fraction? Multiply by the reciprocal. So multiply by 1 over H. What happens to my H's? That one cancels, and now I'm left with negative 9 over A times A plus H. Okay? And that thing right there is your average rate of change. And what's nice about that, guys, that is 95% of the calculus that you're going to do next year, okay, and this type of problem. The next aspect of this question in calculus class says, okay, now what happens when H gets really, 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 really small? Because when H gets really, 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 really small, okay, that means that blue distance is really, really, really small, right? And that means those points, f of A and f of A plus H, those y values are really, 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 really close together on that curve, right? And then if they're really, really, really close together, then that secant line, that dotted orange line that I have up there connecting f of A and f of A plus H, becomes a tangent line, and now we can find the slope of that curve, okay? And we have to, that kind of 5% of the calculus that's left over there, you have to understand what limits are. We haven't talked about that yet. We might talk about limits at some point later on. Usually, if we have time at the end of the year after trig, I start introducing a little bit of calculus to you guys. But this is, like I said, this is 95% of the work for that, okay? When you then learn limits, you apply a limit to that, and you're good to go, okay? Is that all right, everybody? So that question was 12. Let's talk about 11, okay? The only thing about number 11, guys, that I don't, like I said, I don't like is that we're making the assumption that this number here is to the right, okay? So if I'm going to find net change, I'm going to find G